Welcome to Formulaic Utopia. My name is Sarah, and today we are at the Decaturville Crater.
That's great.
Today, we are going to be looking at meteorite landings. We have obtained a data source from data.gov that has recorded meteorite landings through time. So we're going to be using RStudio to be looking at a few visual graphics to explore that data set. And then at the end of today's video, we'll also be taking a short field trip to an actual meteorite landing known as the Decaturville Crater. So let's go ahead and get started. What we're looking at with the following graphic here is we're looking at each meteorite landing, whether it was found or whether it had fallen, each year that had a recorded meteorite. So we are looking at the years of 860 to the year that this data set ends, which is 2013. As you can see right now, we don't have a lot of meteorite landings, and that's because the first meteorite landing was in 860, and the next meteorite landing doesn't happen until about 1400, followed by the third meteorite landing in about 1500. And then around that time, it starts to pick up. But what we can see here is how many meteorite landings, whether it had fallen or had been found, had occurred each year. Okay, so notice how it starts to change through time. As we get into about the 1800s, we can see that it really starts to pick up in speed each year, how many are occurring. And by the 1900s, even more so, with that trending on into the early 2000s. Okay, so what we can notice here from the yearly recordings is that at the very beginning, it didn't seem that meteorite landings happened that often. Recorded or fallen records were not taken as frequently. And then by the time we got to around the 18 to 1900s, that frequency started to pick up each year. So some things that might have changed. We might have had different definitions of what a meteorite landing was, and that might have changed around that time period. We also might have had better technology, of course, during those time periods that would have improved communication and our ability to record meteorite landings. So this is very interesting. And let's go ahead and proceed on now to our next graphic. Okay, so with the next graphic, what we are looking at is cumulative recorded meteorites that have occurred since 860. So you'll notice at the beginning here that we don't have much action, and we won't until we get into about 1400 when the next recorded meteorite landing occurs. But what is different about this graph than the last graph is it's also broken down by the meteorite size. So in the data set, the meteorites also have their mass listed in grams. So I've broken down that different sizing into different quantiles. So the largest circle you see is going to represent the largest sized meteorites within this data set respectively. So once again, you can see that we have quite a bit of action starting to pick up around the 17 to 1800s, and it starts to rapidly speed up 1900s onward. So when we take a look at the cumulative recorded meteorites, especially broken down by size, we can start to kind of wonder, why has this planet not been destroyed yet if there have been so many recorded meteorites fallen and found over the years? And so that's a very interesting question, and I think that the answer to that is best described in our next graphic. Next, we're going to be looking at the mass quantile size groupings of all of the meteorite landings. So we want to get a general idea of what is the size of most of the meteorite landings in this data set. And hopefully that'll give us a little bit more peace of mind about all of these meteorite landings that we have found and have fallen over time. So what we're first going to start by looking at is what is the largest meteorite landing in relation to an actual physical object. And then we're going to look at each of those quantile breakdowns at the 99th, 95th, 90th, 75th, and 50th quantile. So let's go ahead and dive into that graphic. So you can see that the largest meteorite landing is about around the size of an M1 Abraham tank. On the 99th percentile is around the size of an adult female. 95th percentile and less is around the size of a 10-pound rock. 90th percentile and less is around the size of 2 cans of peas. 75th percentile and less would be around the size of a smartphone. And the 50th percentile, the median of the data set, would be around the size of a Bic lighter. So it's important to note that the overall sizes of most of these meteorite landings have been relatively small. The 50th percentile, the median of this data set, is about the size of 0.05 of a pound, which is about the size of a Bic lighter. So 50% of all of the records within this data set are smaller than that given mass. So this kind of helps to explain why, our planet hasn't been completely destroyed by all of these meteorite landings, whether they have fallen or been found records. And it does maybe help to give us a little bit of comfort in the fact that if there is a meteorite landing, statistically, it is a small one. Now, it is also important to note that this data set does include relic records in which the value of the mass was 0. Now, that value is less than, that value represents less than 0.05% of the entire data set. The last graphic that we have to look at today is the top 10 largest meteorite landings by size. The largest meteorite landing that ever occurred was in 1920 in Namibia, and that was a found meteorite. The next meteorite was in Greenland, followed by Argentina, United States, China, Namibia again, Mexico, Australia, Russia, and Mexico makes its way on there twice as well. It's interesting to note that of all of the fall types, most of them happen to be found, 90% of them in the top 10. There's only one that was a fallen fall type, and that was in Russia in 1947. So very interesting. All right. Lastly for today, I did promise that we would take a field trip to the Decaturville Crater. So what we are looking at now is the crater that was left from the meteorite landing. You're looking at the actual asteroid marks there in the gold. And as we look over to the opposite side of the crater, a highway was built right in the center of this course. You can see, though, that the rock is really deformed and smushed in a way that it typically isn't. So it's just, it's very interesting. I'll let you go ahead and just kind of look through all of these images. I highly recommend, if you have any type of meteorite landings within your own state, get out there, go look. Thank you so much for listening. I hope you enjoyed learning about meteorite landings. We appreciate it, and we hope that you'll tune back in again soon.